Welcome friends to One Stop Java Solutions. I am Ascii and today I am going to explain you about the data type in Java. Okay, so in Java actually it supports several types of data. Okay, so today I will explain about the primitive data types. Okay, so data types basically used to declare variable or create any arrays. Okay, so in Java basically it support 8 primitive data types. Okay, so these are the byte, short, int, long, char, float, double, and booleans. So here I am showing you. So I am going to Eclipse, and here you can see I already have created a project YouTube demo. So inside this YouTube demo there is a Ascii folder, and here you can see my package YouTube demo, and inside this package I am creating one class. Okay, so creating one Java class and keeping the name that data type demo. Okay, and I am also creating the main method. So check this main method, this checkbox, and then click on finish, so it will automatically create the main method. Okay, so it's done. Now I am showing you that there is a that I told that 8 data types is there. So for integer type of data, okay, so there is 4 integer types of data in that Java supports. That is, first is byte. Okay, so I'm writing here byte, suppose b. Okay, so byte b, and here means why it support means 4 kind of integers. So you can means it may support only one. Okay, but what is the problem? Because why we'll use the data type to means define the size to the compiler. Okay, so once you declare a variable, suppose here b is a variable and I am declaring this variable with a data type like byte. Okay, so what it will do, it will allocate memory. Okay, so once you assign any value, so it will allocate memories for that variable. So how much memory it will allocate? Because in computer science the memory is very precious thing. So if you suppose for example you are creating one program that you have to store the roll number of student of a class or of a section. Okay, so roll number maximum it might be 100. Okay, or maybe less than 100. So for that you have to means select or choose a data type that will store around 100 data. Okay, so you will not choose a data type that will that can store suppose 1000 data types, so it will wastage of memories. Okay, so for that means your as per your means requirement, you have to choose the data type so that the memory will utilize means you will unnecessary memory utilization you can stop. Okay, so for byte the size is 8 bit. 8 bit means basically it's 8 bit means it's a binary. So if you convert the 8 bit into a integer, so that means 8 1, so it's 2 to the power 8. Okay, that means 2 to the power 8 means 256. Okay, but these are the integers are the signed. Signed in the sense means you can store positive value as well as negative value. So in 8 bit, if you store positive and negative value, that means total you can store that 256 means up to 256. So if you count from 0, so 0 to 255. But if you store the signed values, that means it will be half, means half portion you can store negative values and half portion you can store positive values. That means for minus 1 to 8. Okay, 128 to 127. Okay, so this is the range of byte. So I am showing you that byte b. So if you try to assign some values here, so suppose I am writing 256 here, so here you can see that compiler will give you an error that the mismatch cannot convert from int to byte. Okay, so you cannot convert into byte because the maximum size that a byte variable can store is minus 128 to 127. So if you store here minus suppose 128, so that also not allow, but if you store 127, that will allow. So this is the maximum positive value that you can store in a byte variable. Similarly, negative value 127 is fine. If you store 128, that also fine, but if you store 129, then it will give you error. So you can understand that the range of the byte is minus 128 to 120 plus 127. Okay, so in this range, if you can store any values in this range, then you have to choose this byte data type. Okay, similarly for sort. Okay, so similarly for sort variable, you can store sort suppose s equal to, so here you can store means sort, the size of the sort is 16. Okay, I mean 16 means 2 to the power 16. It's a binary, means 16 bit. Okay, so basically while we are telling that the size of the sort is 16 bit, so that means it's 16 bit, that means maximum 2 to the power 16 value it can hold. But as it is a signed, means all the integers are signed, so that means it can store 2 to the power 15, okay, to 0, minus 2 to the power 15 to 0, then 0 to plus 2 to the power 15. Okay, 15 to the power 15 minus 1, because we are counting 0 as well, so 0 to 2 to the power 15 minus 1. Okay, so this is basically logic. So 2 to the power 15, that means 32,768. Okay, so that is 2 to the power 15, but 2 to the power 16 is double. If you double it, then it is, you will get the 2 to the power 16 values. So sort can maximum store minus, from if you means negative values if you can store in a sort variable, then you have to use, you can store minus 32,768. Okay, that many values. And if you increase it by 1, if you increase it to 9, then you cannot store it. So you can see that the mismatch cannot convert into sort. Okay, so where you are writing this is, if you write here to the but sorry 129, then you get the message that mismatch cannot convert into byte. Okay, so here you can see that this message you are getting. Similarly, while you are means exceed the limit, okay, if you are trying to store a value beyond this limit, then you will get this error message. Okay, so you can maximum storage these values. Similarly, for positive value, you can store up to 2 to the power 67, because here we are counting 0, so 1 should be, means you have to, you can store that from 0 to 2 to the power 15 minus 1, not 2 to the power 15. Okay, so 2 to the power 15. So this is for byte, sorry, this is for sort. Then if you go for int, then in Java int is 32 bit long. Okay, so 32 bit means it's 2 to the power 32 maximum value it can store, but as it is assigned, so here again it is from minus 2 to the power 31 to 2 to the power 31 minus 1. Okay, so this range, so int, if you store that 32, so sorry, int I equal to, so how you will write this, so if you store like this way, means you can use that math function, math dot power, math dot power, and it's take the double value. So here we can like that 2 to the power 31 maximum we can take 2 to the power 31. Okay, so we can store. So it's a double value, so you have to means typecast it. Okay, so for typecasting you have to typecast it to int because it will return the double, so we are typecasting from double to int. Okay, so now if you sorry, you have to print it. So if you print this value I, then here you can see that it give that sub 2147483647. Okay, so this is the basically the 2 to the power 31. Okay, 2 to the power 31, so it can store this range. So if you calculate, okay, so 2 to the power 31, so if you increase it to 2 to the power 32, okay, so it's much bigger, but as you have set it to int, okay, so it's basically return the double values, so we are typecasting it to int, so it will store maximum int. So if you write anything here means 2 to the power 33, if you write here 2 to the power 35, that also it will store the maximum integer values to this int value. Okay, so that is basically 2 to the power means size is 2 to the power 32, so it's that means 2 to the power 31. Okay, so why it is 2 to the power 31? Because it's signed. So for signed, if it is not signed, then you can store maximum 2 to the power 32, 2 to the power 32, the whatever value would be, it would be, so it will you can store that in integer values. But as it is a sign, so in that case you can store 2 to the power 31 means for negative value, so minus 2 to the power 31 to 2 to the power 31 minus 1. Okay, so that is the range. So that means, so whatever you have right here, as I am means converting it to int, so it will means truncate, it will store the maximum integer value that an integer variable can support. Okay, so that is basically 2 to the power 31. Okay, so that value it will store. Similarly, if you want to negative, so if you run it, so it should be instead of 47 you can see here 48. Okay, so this is the maximum negative value an integer variable can hold. Okay, so whatever you have right here, I am calculating the power, so whatever instead of 35 if you write 37 also, so then in that case also you will get that much value only, because an integer variable can hold maximum this value. Okay, so this is int. Similarly for long, if you write long variable long L equal to similarly you can perform this math.pub, and here also you have to typecast it to long. Okay, and instead of I just print L, and here so long size is 64, that means you can maximum store as it's also the signed value, so maximum you can store 2 to the power 63. Okay, 2 to the power 63. So if you okay, it's negative also is. So if you just run it, so here you can see this is the values of the 2 to the power means long value. So a long variable can maximum store this value. Okay, similarly for negative, it will, if you write here minus, okay, and instead of 68, suppose I am writing 68, so it will maximum store 2 to the power 65. Okay, so it's 8, you can see here it is 8. Okay, but for positive value it will must means this is a negative, so negative range is 1 more or greater than the positive values, because for positive we are counting from 0. Okay, so 0 is being included, so that's why you will got it's like 0807. Okay, so 2 to the power 63 or 65 you can write here for negative, and if you remove it, so you will get this value, that is till 807. Okay, so it's clear that long can maximum store 64 bits. So this is the maximum value that a long variable can store. So whatever the power will return, so it is a basically it is using the double, so double size is much more than that. So if it's written the double and we are typecasting double to long, so whatever long can hold the maximum value that will store in this variable. Okay, so this is the maximum value that a long variable can hold. Okay, so now it is clear that whichever means whatever as per your requirement you can choose the data type. Okay, so if you have to means you have to calculate some maths or something, some problem where you have to means the value of the any variable might be reached to this range, so in that case you have to use this long. Otherwise you can means for means less number means compared to long. Okay, compared to long, if you can means if your program or if your declared variable will store a shorter range, then in that case you have to use the int. For more shorter range you can use the short, and for byte you can just store minus 127 to plus sorry minus 128 to plus 127. Okay, this range of values, so accordingly you have to choose your data type. Okay, so these are for the integers. Okay, so here no fractional point you can store, so you can store some suppose like this way. So as Java support the type conversion, in my previous video I already described what is the type conversion. So here also if you type means suppose you are declaring an int and you are storing some suppose 10.5. Okay, so 10.5 value. So what Java will do, so here you can see compiler will give you the some that you cannot mismatch, cannot convert from double to int. So here you can do one thing, just typecast it to int. So you can, by typecasting you can do anything. And now if you print these I values here, so what it will do, it will truncate the precision. Okay, 10.5, so 0.5 it will truncate. Okay, this precision value it will truncate, and it will print the means it will hold only the integer part. Okay, so this is the typecasting. So by typecasting you can do, but in normal case for any floating point number, to store any floating point number, that is the real number, means all integers can only hold the whole number, but for floating point numbers, okay, if you store in a variable, so in that case you have to use either double or float. Okay, so here also the double and float, if you means think about the double and float, then here also it's basically the size. Okay, means they are differed by size. So for float it is a 32 bit and for double it is a 64 bit. Okay, so here I am showing you one example. So for floating point types, there is means Java support only these two, one is double and one is float. So here I am using double t equal to, suppose I am writing 10 by 5. Okay, so double t equal to 10 by 5 and float f equal to also I am writing 10 by 5. Okay, so and here I am printing t and similarly printing f, t and f. Okay, and if you run this, so here you can see that it's both are 2.0s. Okay, so here if you suppose if you write 500 and if you here also do the 500 and if you run it, then here you can see it's giving the 0.0. So why it's basically giving this, so you have to convert. Okay, so first one is the double d, so here 10 is a integer and 500 it's also integer. Here 10 is a integer and 500 also is integer. So here you can do two things. So it is a integer calculation basically, so that's why it's giving the 0.0. You are storing the double. So here you can, one thing you can do, that you can typecast it. Okay, so you can typecast it to double, and here also you can typecast it to float. Okay, so that is one. So here you can see it is a 0. So if you write some more values, do it, and if you run it, so here you can see that it's giving some exponential part also, 2.0 and e minus 5. That means it is 2.0 into 10 to the power minus 5. Okay, basically here e means 10 to the power minus 5. So if you means convert it in means divide it by 10 to the power minus 5, then you will get means 2.0 into 10 to the power minus 5, whatever value is that is the values of this calculation. Okay, so this is one thing that you can typecast this one. Another thing is to declare the float or double variable. So you can just declare after 10, if you write d, that means it is a double. Okay, so to define a double means double value, so you can after the value you have to write d for double, and for float also, if you remove this float, instead of means using the type conversion, you can just write f after the variable values of this variable. Okay, so that means it is a float 10f, that means it is a float value. Okay, and it's also float value, and here it's the double value, and here also it's double value. And now if you run it, so here you will get the same values. Okay, so these are basically the similar kind of things, but here some means there is a difference, that precedence. Okay, so single precedence means float is a single precedence and double is a double precedence, and double precedence is much faster than the single precedence. Okay, so in most of the means arithmetic function or trigonometric function is using the double values, like sine, cos, sqrt means square root of a value. So these are using the double value. So power, in case of power, I show you in last example that if you write here some math.power function, math.power, so here you can see that it's also take the double and it's return the double values. Okay, so it will return the double values. Okay, so most of the means mathematical function is using this double. Okay, so double range is 64 and float range is 32. Okay, so that means it can, so to the 64 bit. Okay, total size of this double variable is to the 64. Okay, that means it's 64 bit length, and float is 32 bit length. Okay, so these are the floating point representation in Java. So we can represent them using double and float. Okay, then the character, for character it is use char. Okay, so for char I am showing you, and Java use the Unicode character set. Okay, so char, see, so in case of Java char, it is a 16 bit. 16 bit means 2 to the power 16. So it's a huge range. So it almost means support all the means local languages, okay, in the world. So every languages it support. So it's the Unicode, it's defined the full international character set, okay, that can represent all the characters found in all human languages, almost all human languages. I will not say that all human languages, but almost all human languages. Okay, so it ranges huge. It's 2 to the power 16. That means it is a 65,536. Okay, so it's huge. So here if I declare char c, and here you can store anything, means any character, any number, okay, or any alphabet and any special character, everything you can store here. And in case of character, you have to means one, suppose a, if you store a is a character, so you have to write a in a single quote. Okay, so this is the means procedure to declare a character variable. And if you suppose print the value of c, then it will print the value a. Okay, here also you will get the means you know about the Ascii values. Okay, so Ascii values of means Ascii means it is a American standard for information interchange. So every character has Ascii code. Okay, so if you want to know the ASCII code of A, so here suppose int A equal to C. Okay, C is a character variable and A is a what is, suppose int I, instead of I am writing I. So here C is a character, so I am converting character to int. Okay, and if I print this I here, so you will get the ASCII value. Okay, so ASCII value for small a is 97. Similarly, if you write the capital A, here you will get the ASCII value of capital A, that is 65. Okay, so capital A is 65 and it is 97. Similarly, if you write the capital B, so it would be 66. Okay, like this way, 66, 67, like this way you will get all the means ASCII values of capital alphabets. Similarly, if you write small b, then it is 97 is A, so 98 would be small b, 98. Okay, so in that way you can convert the character to ASCII values. Okay, and almost all the character you will store here. So if you write the suppose star here, so ASCII value of star is, you will get 42. Okay, similarly if you use the 0, okay, so it's I guess 32. 0 is 48. Okay, 1 49. Okay, 0 is 48 and 1 is 49. Okay, so similarly if you write 8, so you will get the ASCII values of 8. So ASCII values of 8 is 65. So as a character set, ASCII value of 8 is 56. Okay, so like this way you can convert character to ASCII values. Okay, so you can you want, if you want to know the ASCII values of any character, so you can get it by using this code. Okay, next it's Boolean. So Boolean basically it's also a primitive type, and it's basically used for the means it's only can store two values, one is true and one is false. Okay, and this type basically it's written by all the relational operation. Relational operation means suppose if statement. So if a greater than b, or if a greater than less than something, so in that case these are the means greater than, less than, equal to, these are the relational operator, and these all the means operation or operators, these relational operators will return these values either true or false. So these are the boolean. So I am writing here code that boolean, you can like this way you can use boolean true, sorry, boolean b equal to true. Okay, you can only use true and false, except that if you means try to assign anything else, suppose a, so here it will give you error. Okay, so you will get compile time error. So you can only store the, suppose if you write 10 boolean b equal to 10, then also it will give the compilation error. So you can only either true or false. So while that is the thing, and suppose in general what we will write true, and in case suppose we are writing like this way, if suppose 10 greater than 5, then we will print some message. 10 is greater than 5. So this message I want to print. So if you run it, so it will execute it, 10 is greater than 5, and else otherwise I will print in this message that less than. Okay. So here I will write else 10 is less than 5, less than 5. So if you now execute, so the first line will execute the 10 is greater than 5. Now instead of doing, if you write true, so basically this is a boolean, this is a relational operation. Okay, and it will return a boolean values either true or false. So instead of any expression, you just write here true. So if that means true, so that means this part will execute, so first part will execute here. So if true, that means 10 is greater than 5, and if you write here false, that means this part will never execute. Okay, so second part, else part will execute, so 10 is less than 5. Okay, so this is the means functionality of the boolean value. So in case of any relational operator, it's return the boolean values. Okay, so this is the boolean value, and it can either store means true or false. Okay, so that's it, means these are all are the primitive data types. So there is 8 primitive data types. So first one was int, then sorry, not int, the byte means integer type. There is 4 integer type, that is byte, short, int and long. And then we discuss about the floating point types. Floating point is float and double, and for characters only char. Okay, and for booleans it's booleans. Okay, so these are the okay, so these are the from, so then so we already discussed byte, then short, then int, long, okay, char, float, double and boolean. Okay, so these are the 8 primitive data types, so that we all discussed. Okay, so hope it's now clear. Okay, what is data type and why we use this data type. So hope it's clear, and if you like my videos, you can share with your friends, and you can subscribe my channel. And also in the means if you have any queries or any question or any feedback you want to give, so you can give me in the chat box. Okay, and also in the description box you can see that there is a means my channel link is there, so you can go there and watch the relevant videos. Okay, so in my channel I am basically describing and solving different problems, and also I am describing code Java, advanced Java and website design related topics here. And also in the bell icon you can click, so that once I upload the next video you will get the notification. Okay, thanks for watching this.